So the second half of Module 2 is all about Chapter 3, and we're only going to hit up the last 3 sections of Chapter 3, which 3.4, which we're going to talk about right here, is all about long division with polynomials. And then 3.5 and 3.6, super important sections, all about factoring. Okay, so let's start chapter 3 with section 3.4, and let's talk about long division of polynomials. It's not too terribly crazy from what you have done before when you learned how to do long division of numbers. Okay, so for instance, let's take this long division problem right here. So we want to take 175,332 and divide it by 7. So remember in long division, kind of the goal was we wanted to cancel out each number as we went along. It was great if we could cancel out each number as we went along, but sometimes it wasn't possible and we got really, really close to it. But the process of performing long division between two numbers is going to be the same kind of process when we perform division of polynomials. Okay, it really is a 3-step process, which when you do long division of numbers is a 3-step process. Okay. So let's talk about this real quick. And I only have 4 examples after we talk about the basic principle, the basic ideas behind long division. So the first thing is you want to try and get rid of 1. Well, can 7 go into 1? No, it's impossible. Okay, so then the next number we focus in on is we want to try and get rid of 17. Can 7 go into 17? Not perfectly, okay, which we would hope it would, but we can get to a number that's close to 17. For instance, 14. Okay? So how many times can 7 go into 17? 2 times. And 2 times 7 is 14. Okay? So when you're thinking about this, we want to know how many times can that 17 go into this, which for us was 2, and 2 times that 7 gives 14, and then all you do, remember, you just subtract down. 17 minus 14 is 3, and then everybody else back here trickles on down like Tetris. Da, na, 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 and there they are. And then you repeat the process. 7 can't go into 3, but can 7 go into 35? Absolutely. It goes in evenly. It goes into 35 5 times. So 5 times 7 is 35. And then we subtract down. Okay? And that gives us 0, which is great. And everybody else trickles on down. Okay? Now we repeat the process. Can 7 go into 0? No. Can 7 go into 3? No. So again, remember you got to have placeholders up here. Can 7 go into 33? Absolutely. It can go into 33 4 times. Okay? And 7 times 4 is 28. Okay? And then we subtract down. So remember that you do a little bit of carrying. 13 minus 8 gives us 52. Okay? And then you repeat the process one more time. 7 can't go into 5, but it can go into 52 because we brought that 2 on down, like Tetris. So how many times does 7 go into 52? Well, it goes in, let's see here, 7 times. 7 times 7 is 49. And then we subtract down and you get 3. Okay? And then that was the remainder. And as the remainder, you really just take the remainder and you put it over what you were dividing by. And there you go. There's the rest of the decimal. Okay? So this part right here, this nice little colorful number that we have right here, this is what we call the quotient. And this guy over here is what we call the remainder. And in your assignment, they're going to want to know these things. They're going to ask you a blank for the quotient, and then there's a blank for the remainder. Okay? So notice, basically, it was all about how many times can this go into what we want to get rid of. We write it down, then we multiply, and then we subtract down. That's the idea. Number of times it goes in. Then we do a lot of multiplying. And then we subtract down. Okay? So that way it just don't look like two dots. All right. So let's take a look at some examples here. First, let me tell you how we set these up for long division. Okay? Because these things are going to come at you two different ways. They're going to come at you horizontally like this, where the first parenthesis goes under the division symbol. The second parenthesis is what goes out front. Okay? And now it's set up. If you have it as a fraction, the numerator goes under the division symbol. The denominator is what goes out front. And now these are ready to perform long division. So again, just to remind you, first parenthesis, if it's written horizontally, goes under the division symbol. Second parenthesis goes out front. Numerator goes under the division symbol. Denominator out front. Okay? So just a guide. First, well, sorry. Let's do this. Second parenthesis, division, first parenthesis. In here, numerator, denominator. Okay? All right. So now, let's do some division. Here's how it works. This is like that first number we were trying to get rid of over here, the 17. Okay? What's cool about this, when we do polynomial, what you care about is this first guy right here. We want to know what times my x here will give me this guy right here. This is the guy that we want to get rid of. Okay? And that's basically what we were asking, the number of times it goes in. What times 7 will give me a number that it is either 17 or below it. That's the question you were asking. What times 7 will give me a number that is 17 or below? Okay, should actually look like that. We love it if it was equal to it, but it could be, we'd have to sometimes go with below. But when we do it over here, it will always be equal. Okay, you won't have to be in below this. So what times x gives me x squared? X squared. See, that's how many times x goes into x squared. It goes in x times. So now, just like what we did over here, we're going to multiply. So we're going to take x times everything in front. It's like distributing. We're going to take x times all of that x minus 1. Okay? So what's x times x? X squared, which we knew was going to happen. What's x times negative 1? It gives me negative 1x. And then what do we do last? We're going to subtract down. Okay? And when we subtract down, we know that this guy is going to go away. We know that. We're engineering it so this guy cancels out. Okay? But now you got to be careful over here with what's going on. Most of you are going to be like, oh, this is 2x. And I'm going to be like, no, it is not 2x. because what you're doing, remember, you are subtracting down. So this is 3x, and I always write this information out. 3x minus a negative 1x. See, 3x minus negative 1x. Okay? So what happens with a negative by a negative? It really turns into a plus. So what you're really dealing with is 3x plus 1x. And that gives us 4x. And then just like before, how all these extra numbers trickle down, everything else right here will trickle down. There it is. Okay? And all you do now, repeat. You're going to repeat those same 3 steps. Except this time, we have a new piece that we want to get rid of. Okay? So we're going to say, what times my x, we're still going to use this guy. We always use that guy to begin with, equals this guy, 4x. So what times x equals 4x? Well, hopefully you realize that that is a 4. And now that we're putting it up here, because these are polynomials, is this a positive 4 or a negative 4? And you're like, it's positive. And I'm like, yes. So make sure that you show me it's positive. Put a plus sign there. They want that. Okay? So all we're going to do now is we're going to take this 4 and we're going to multiply the x minus 1. 4 times x minus 1. Okay? So 4 times x is 4x, which we knew would happen. And 4 times negative 1 is negative 4. And then what do we do now? Subtract down. So we know that those guys cancel out. And then I always look at what I have over here. So I have a negative 4 minus a negative 4. So no, this is not negative 8, if that's what you were thinking. But what happens is a negative by a negative becomes plus. So this is really just negative 4 plus 4, which is 0. And the best part, because this is 0, I stop. I'm done. So in my answers, this is what they're going to look for. They're going to say, what is the quotient? Which in the blank, you're going to put the polynomial that you have up here. X plus 4. And then it will say, what is the remainder? And then all you got to put is 0, because everything canceled out. Okay? We'll talk about what happens when there is a remainder. But that's long division. That's all you're doing. It's the same stuff. Now, another way you can do, I just want to mention this, another way you can do the subtracting down. Some people know that if you're doing subtraction here, then what they like to do is they like to change this to addition, so it's adding down. But if you change this to addition, then you have to come in here and change all the signs. Okay? So some people like to think of this as adding down, but you're adding down the opposites of what you see here. So a positive x squared became a negative x squared. A negative 1x became a positive 1x. And so if I add down, these two still cancel out, because 1 plus a negative 1 is 0, and 3 plus 1 is 4. And then again, you could do the same thing down here. Instead of thinking this as subtracting down, you can think of this plus, whoops, not erasing, plus all the opposites down here. So this is a negative 4, and that's a positive 4. I always just think about it as the subtracting. That's just what I do, because it really is subtracting down, okay? But it's your choice. If you like to change subtracting down to adding down, just remember that all the signs down here have to change. You do you, but I'm always going to do the subtracting down. I'm not going to change it to plus all the opposites. All right. Go ahead and give this one a shot. And go. Okay. So when you're going through this, here's the guy we care about. Here's the first piece we want to get rid of. So we're going to say what times x equals 2x squared. Well, hopefully you said 2x. That's right, because 2x times x gives me 2x squared. So we're just going to do some distributing. We're going to take 2x times x plus 3. Okay? So 2x times x is 2x squared, which we knew would happen. And 2x times 3 is a positive 6x. And then what do? We subtract down. The x squareds cancel. And then this right here is 3x minus 6x. So what's 3x minus 6x? Negative 3x. And the plus 7 over here trickles on down. Trickle, trickle, trickle. All right. And now you have a new piece to get rid of. So we're going to say what times x, because we still like this guy right here, gives us negative 3x. And hopefully you said that it's a negative 3, Mr. Armstrong, and you showed me that. See? Negative 3. If it was a positive 3, we would have said plus 3, like what we saw in that first example. And so we're going to do some multiplying. We're going to take negative 3 times the x plus 3 in front. So negative 3 times x is negative 3x, which we knew would happen. And negative 3 times 3 gives us negative 9. And all we're going to do now is subtract down. So this piece is 7 minus negative 9. Negative by a negative becomes positive, and if you take 7 plus 9, you get 16. And then this is where you're going to stop. Because if you try to get rid of the 16, it's not going to work. Because what you'll be looking at here is what times x will give you 16. And nothing times x will give you 16. Okay? At least that we care about. So that's where you stop. Okay? So that means we actually have a remainder this time. And this is how the remainder really looks. When you have a remainder, all you do is you add it onto the end of the quotient. And just like what we did before, we took the 3 and we put it over the 7. We're going to do the same thing here. We're going to take the 16 and we're going to put it over the x plus 3. And that's how the remainder really looks. But our assignment wants it like this. What's the quotient? And there's a blank. And what's the remainder? And there's a blank. So, what do you think goes in the quotient? You're absolutely right. 2x minus 3. What goes in the remainder? Just the 16. They don't want you to put it over the x plus 3. They just want the numerator. Just this number right there, 16. That's all they want in the remainder. Okay? So don't make the remainder look like a fraction, even though that's what it really should look like. They just want to know what is the numerator piece. Okay? All right. Go ahead, give this one a shot. What? You guys are having problems? You didn't pause the video? What's the matter? And yeah, usually in class, when I give you this one, I have lots of students, like some of them go off to the races and do this, but in the end, once you know they finally figured out what happened, they got to go back and redo some things. Some of you, hopefully you noticed that when you wrote this out, there was a problem. The piece under the radical looked, or not radical, under the division sign looks like this. This is not the problem because this is the first parenthesis. It's A-okay. The problem is the second parenthesis. If you look at this, it is x squared plus 7 plus 4x. What's wrong with that? Whenever you do polynomial long division, one of the big things is you must make sure that you are in standard form. Both polynomials need to be written in standard form. Let me fix this real quick. Okay? So that's a huge key right there. Must be written in standard form. Okay? So standard form means that you are from the highest power on down. See, look at this. 3, 2, 1. That makes sense. It's from my highest power 3 on down. 3, 2, 1. Now, look at this one. 2, 0, 1. Because remember, any variable that doesn't have a power, that there is a power there, it's the number 1. Does that make sense? Do I count like that? On your marks. Or actually, on the count of 3, we're going to go. 3, 2, 0, 1. Is that how we really count? No, that doesn't make any sense. I don't go 5, 4, 3, 2, 0, 1. I don't count like that. I count 5, 4, 3, 2, 1, 0. Okay? So that's the problem with this, is that you need to make sure that all of your polynomials are in standard form. And if the ones that we did earlier were in standard form, we didn't worry about that. See? 2, 1, 0. 1, 0. Standard form. 2, 1, 0. 1, 0. Standard form. Okay? So in here, think of these like each piece is its own separate little piece. Like the x squared is its little piece. The plus 4x is a little piece. The plus 7. And it's like you're moving blocks around. So I'm going to move the plus 4x after the x squared, and I'm going to move the plus 7 after the x. And see, now look at this. 2, 1, none. Now we're good to go. So always make sure that everything is written in standard form. From the highest power on down. 3, 2, 1. Good. 2, 1, 0. Good. Okay? And then now you can do the long division. Go ahead, pause the video, and give this one a shot. Go. Okay. So here's who we care about. Here's who we want to get rid of. So we want to know what times x squared equals 3x cubed. So hopefully you said 3x, Mr. Armstrong. And I'm like, yes, you are absolutely correct. 3x gives us that. Okay? So now we just multiply 3x, and we got to multiply it by all of these. X squared plus 4x plus 7. Okay? So 3x times x squared is 3x cubed, which we knew would happen. 3x times 4x, that gives us plus 12x squared. See, notice everything's lining up. And 3x times 7 gives us plus 21x. Okay? And all we're going to do now is subtract down. The x cubes cancel, which we knew was going to happen. Over here, we got two subtractions that we got to be careful of. We have negative 5x squared minus 12x squared. See? Negative 5x squared minus 12x squared. And that gives us negative 17x squared. And then over here, we've got 4x minus 21x. So 4 minus 21 gives us negative 17x. Okay? And now we're ready to repeat because nothing has to trickle on down. All right, so now here's the new person we want to get rid of. So what times x squared gives us negative 17x squared? And that will be negative 17. And so we're going to take negative 17 times that entire beginning piece, the x squared plus 4x plus 7. So negative 17 times x squared is negative 17x squared, which we knew would happen. Negative 17 times 4 gives us negative 68x. And negative 17 times 7 gives us negative 119. And again, all we're going to do, subtract down. So we know that those cancel out. Now we have negative 17x minus a negative 68x. Well, two negatives by each other become positive. So it's really negative 17 plus 68, which is 51x. Now over here, notice there's nothing above here. Well, actually there really is. Up here, if I really wanted this all the way in standard form, I could say this is 3, 2, 1, and since there is no 0, since it's missing, I can put in a placeholder and just call it plus 0. So now it goes 3, 2, 1, 0. And down here, that placeholder is actually really there. So even though it looked like there wasn't anything to subtract, there really was a number there. It was 0. So we're going to take 0 minus negative 119, which just becomes a positive 119. And that's where you're going to stop. Because again, the next step, you're going to try and get rid of 51x. So you're like, what times x squared gives me 51x? And there isn't anything, because I can't take x squared and go backwards to just a regular x. It's not going to happen. So now you have all your information. So all we need to know now is, what is the quotient? And what is the remainder? So your quotient is 3x minus 17. Your remainder, 51x plus 119. And it's okay that this remainder has variables in it. That can happen. These are polynomials. Okay? And there it is. Technically, though, if we were really writing this out, the remainder should look like this. 51x plus 119 all over x squared plus 4x plus 7. That's what the remainder should really look like. Okay? All right, last problem. Go ahead. Pause the video. Give this a shot. What? Again? You're having problems? Well, let's take a look. And yes, again, you should have, a minor hiccup on this one. When you write down the numerator under here, so you got x to the fourth. Yeah, fix that. X to the fourth, okay? And then you have plus 7x squared minus 2x plus 11. If you look at this and count this, it says 4210. 4210. Yes, that is in standard form. I agree. But the problem is, do you really count like that? On your marks, get set, ready, 4210, go. What happened to 3? Okay, so another piece, and I kind of touched on it right here, but I just didn't talk about it. Remember how I added this placeholder, a plus 0, because the 0 term was missing? See, 3, 2, 1, but there was no 0 here, and we put in the plus 0. Well, the same thing has to happen that. So not only do you have to make sure that you're in standard form, but you have to make sure that all degrees, or I should say powers, are accounted for. All powers must be present. So if you're missing a power, as in this case, 4210, that's a not normal. So since we're missing the 3 in here, we're going to add in that 0 placeholder. Now, if you count it, 4, 3, 2, 1, 0, that makes more sense. And it sounds right. And then in front, you have the x squared minus 6x plus 5. Now pause the video and give this a shot. Go for it. And those are the only tips and tricks that you need to remember about polynomial long division. Make sure you're in standard form, and make sure that all powers are there. We're not missing anybody in standard form. So 4, 3, 2, 1, 0. That makes sense. 3, 2, 1, 0. That makes sense. Okay? All right, pause the video, go. Okay, so here's who we care about. Here's who we're first trying to get rid of. So what times x squared will give us x to the 4th? And hopefully you said x to the 4th. Okay? So now we're going to take this x to the, oh, sorry, not x to the 4th, x squared. Silly Mr. Armstrong. So now we're going to take this x squared, and we're going to multiply x squared minus 6x plus 5. Okay? So x squared times x squared is x to the 4th, which we knew would happen. And this is another reason why we need that placeholder of x to the 3rd, because x squared times negative 6x is negative 6x to the 3rd. If I didn't put in this 0, x to the 3rd, this one would have nothing to line up under. It would be placed over here, which would be weird. We don't want to place an x to the 3rd all the way over here. We want it to go across naturally. Okay? So that's another reason why we have this x to the 3rd, because when I take x squared times negative 6x, that's negative 6x to the 3rd. And I need that guy there to line up. And x squared times 5 is 5x squared. All we do now is subtract down. So the x to the 4ths cancel. This becomes 0x cubed minus a negative 6x cubed, which becomes a positive 6x cubed in the end. And over here, you get 7x squared minus 5x squared, which gives us a positive 2x squared. And we bring everybody else back down. Okay? So now we repeat. Now we have a new guy to get rid of. So what times x squared will give us 6x cubed? And hopefully you said a positive 6x. And so now we're going to take 6x times x squared minus 6x plus 5. So that will give us a 6x cubed that we knew. 6x times negative 6x is a negative 36x squared. 6x times 5 is a positive 30x. And subtract down. So the x cubes are gone. Here we have 2x squared minus a negative 36x squared. So that gives us a positive 38x squared. Over here we got negative 2x minus 30x. And so that's negative 32x. And then the plus 11 trickles on down. And you're going to keep going, because the next one can actually happen. Okay? So here's who we're trying to get rid of this time. So what times x squared gives us 38x squared? And hopefully you say that's a positive 38. And so we're going to take 38 times x squared minus 6x plus 5. Okay? So that gives us the 38x squared that we were looking for. 38 times negative 6 gives us negative 228x. And 38 times 5 gives us a positive 190. And all we're going to do now is subtract down. Okay? So we know that these two cancel out. And then now we've got negative 32x minus negative 228x. So that's negative 32 plus 228, which gives us a positive 196x. Okay? And then the last guy is 11 minus 190. So 11 minus 190 gives us negative 179. And now you have all the information you need to answer the problem. This guy right here is your quotient. And then this one right down here, that is the remainder. And that, my friends, is section 3.4. You got this.